Hi, good morning and good evening all. So here I am with the third video that is called Hadoop Advanced. In this Hadoop Advanced video, I am going to discuss about the Hadoop internals and all the basic and the advanced details in the Hadoop architecture. So let's get started. Basically, Hadoop is divided into two components. One is storage and computation. So storage is actually distributed, computation is also distributed. So you have n number of nodes, machines. Your data is distributed among different storage, that is called distributed storage, and your computation is also distributed because your each nodes is having a storage and computation both. So your computation is also distributed. And finally, the task you're going to perform, that's also you can compute parallelly. So that's what we have, two components. Next is distributed file system. So what is distributed file system? So in a network, all these computers interconnected is called distributed file systems. So this is a distributed environment. So let's say this could be one of your computer, this could be one of your laptop. So this each computer and laptop is called a node. So each are interconnected. So each one is capable of distributing the large file into different data nodes and parallelly compute the process. So that's how it's very fast. So nodes, a node is nothing but a computer like your laptop. It's every node is capable of capable of processing data and storing the data. So this is the picture of cluster. So we are going to detail discuss more here. So Hadoop cluster is built of two things that mainly is called master or name node, slaves or data node. So slaves are nothing but a different computer. So let's say every slaves or every data node, each data node is capable of storing data and processing data, storing data, processing data. So these all are interconnected. So these all are called as a slaves, means they are the actual performer, they are the actual developer who are doing the work in a project. So these are the actual engine which is going to perform all the tasks which master is going to receive, and all these slaves or slave nodes are connected to the master node. So this is the very intelligent machine, that is master. This is able to keep track of all those nodes, what are the data nodes available, which are performing operation, which are reading, which are writing. These are secondary master nodes. You can have more secondary master nodes. So this is basically, it's a copy of the master. So it will be treating as a backup of the master. So master node is basically it's not doing anything, it's just communicating to the data nodes and slave nodes, distributing the task, take the task, combine it and give to the user. So that's all is all about Hadoop cluster. Real cluster. So this is the real cluster, this is the Yahoo real cluster. So you can see here, these each are the one cluster, second cluster, third clusters. So in each cluster you can find this is the rack, this is rack 2. Inside each rack you can find these are data node. So these are the actual computation engine and storage engine. So this is how the Yahoo cluster looks like. Hadoop components. So basically there are two components in Hadoop. One is storage and one is processing. For storage there is HDFS, for processing there is MapReduce. So we'll go and see each in a very detail how each engine are going to perform. So these are called engines: secondary name node, data node, job tracker, task tracker. These are called engines and also called daemons. So once you configure your Hadoop and you start your Hadoop, these daemons would work. These daemons would run in order to drive the Hadoop ecosystem. So we'll first cover the HDFS storage. So what is the HDFS storage? So it is used to store and manage huge amount of data in cluster of machines. Let's say you have a petabytes of data or zettabytes of data. Right now we are generating data exponentially. Right now as per the current statistics, we have 45 zettabytes of data already generated. So as example, if we have one CD and we can distribute it to 7.56 billions of population, so it will constitute 1 zettabyte of data. So think about how many data are already generated. So in this trivial's machine, if you want to perform and if you want to do any insights and any analysis on those data, it's not able to perform in a single machine. So that's why Hadoop come into picture. That's why Hadoop solves the problem. So Hadoop is SDFS is distributed file system, so stores and manages huge data. It is scalable and provide fast access. Scalable means as your data get increase, you can scale your hard drive, you can scale your computer, you can add more nodes to the existing cluster, and provide fast access because it's doing parallel processing, parallel computation. Fault tolerance, uh, by default it's it used to detect which nodes get down, which nodes get failure. So automatically what it will do, it will create a copy of that, but copy of each node in another nodes. So if any nodes get down, it will identify automatically, uh, then identify where the copy of the nodes is, then start the computation again from the copy of that nodes. So basically it's fault tolerance. The user doesn't have any feeling that something went wrong behind the scene. So it's very resilient, as you can see. Processing logic, in normal, it's here in HDFS storage, processing logic is close to the data rather than data close to the processing logic. That means in normal, in our C# code, what happens, you have to your code has to pull the data, perform some operations, then save the data back to the uh, storage engine. So but in HDFS what happens, all this processing logic will move to the data. So if you have any performance, if you have to perform big task, all these chunks of algorithms or tasks will move to the data, will move to the data node, perform that operation, then come back with the code. So that's here the main advantage of this. Processing logic is moving to the data rather than data moving to the processing logic. Efficient by distributing the data, it's very efficient and doing the parallel computation. Reliability, we'll see much in detail in future slides how it's very reliable, because it's maintain multiple copies of data in case of any failure. So we'll discuss more. So let's move to the next slide. So functions of a name node. So what are the name node functions? What are the master function? So it directs the data nodes, that is slave nodes, to execute the low level operations. So actual work which data name node got, it directs that tasks to all the data nodes. It's divide the task where the data is, it tell the data nodes where all this data in order to need fulfill the particular task. So it directs all the data nodes. Also it records all the metadata. Metadata means data about data. It will keep track of which node is available, how many number of nodes in a cluster, how many nodes consisting number of blocks inside a single node, which node is free, which node is down, which node is performing, which are down, which are writing, which are reading the data, and all those. So it's basically keeps all this information. So it's a very highly intelligent programming is involved there in NameNode. So and in every 3 seconds, heart NameNode receives a heartbeat from each of the data nodes. So it will report back in every 3 seconds whether it is up, performing well, or it's down. So in every 3 seconds it's have a report of all those data nodes what are doing, which anybody is down, or if anybody is down, how to move further, how to get a copy of all those. So these are the engines. Once you start a cluster, these are the engines always running. So these are called also daemons in Hadoop. So data nodes, first daemon is data nodes. It is the actual the job performer who is doing the low level operations, reading data, writing, and doing the processing logic. The second one is they regularly send a report to on all the blocks present in the cluster to the name node. They periodically send a report how many blocks are freed, how many blocks are available to the name node, so that name node is ready with the next level of tasks. Third one is data nodes also enables pipeline of data. So which data is going to process first, which node is nearer to perform the what the operations we are looking. They forward data to the other specified node also. So they can forward the data to other nodes. And as we already discussed, data node send heartbeats to the name node once every 3 seconds to report the overall health of HDFS. So name node is having the overall health of HDFS, how whole cluster is performing. Next, move to next slide. So these are the concepts. So we already discussed. So this is a master worker architecture. Actually, HDFS is master worker works on a master worker pattern. So name node we already know, it manages the file system directory, structure, and metadata for all the files. This information is persisted on local disk in the form of two files. So basically, name node is keeping all the metadata, and these metadata is used to save in two forms of files, that is FS image and edits. FS image is the master copy of the metadata for the file system. So whatever the data information about data of a data name node is keeping, it's keeping in the FS image. And edits is the every time, let's say any node is any node is changing the FS image, so it's keep log of the data. So every time, let's say in any FS image, keeping all those records, who is performing what, who is performing not, who has completed the operation. So in every alteration, in every delta modification, the new file will be generated, that is called edits. Secondary name node is the backup of the primary name node. So in case of name node itself get failure, secondary name node will serve as a purpose. So data node is the actually workhorse daemon that is responsible for storing and retrieving blocks of data. So this is how the internal architecture of cluster HDFS cluster. So you can see we have name node here, FS image edits, secondary name node FS image edits, data node 1, data node 2, data node 3, and these are the blocks 1 3 4 5, 2 3 4 5, 1 3 2 5. These are the blocks. So here you can see your client can communicate to data node, your client can communicate to name node, your name node can communicate to data node can communicate to name node, but secondary name node can communicate only to name node, because it's keeping the copy of this name node. So every time name node getting changed with the latest FS image and edits, it keep updated with those records, and it is ready whenever its name node get failure. So it's ready with all those copy of the name node. And here what happens, let's say all over the task you are getting to perform, this has been divided by name node to different data nodes, so distributed. So suppose, let's say you got a big file, name node distributed all those data in a pieces. Let's say it created 3 pieces. First piece went to data node 1, then data node 2, then data node 3. Also computation is individually getting performed on each nodes, and again each nodes is again divided into blocks. So we'll see in later slide a detail what is blocks. So let's say this data node itself fails. So these three are doing the computation. So this will give you the partial computation, and name node work is that the magic behind the name node here is it will collect all the record, combine all the outputs and send back to the client. But what if in between this data node itself get down? So in the later slide we'll understand how HDFS is handling in case of failure. So let's say what is HDFS blocks. So let's say you got a big chunk of data, chunks of blocks data you got, and you have to perform some analysis. Let's say you have to count number of unique words used in that in all the blocks, which parties names has been used, either it's a Congress or it's a BJP or it's CPM. How many parties names has been utilized in this whole bunch of blocks. So what HDFS will do, it will divide into blocks in pieces of data. So let's say 225 MB of data we got, HDFS divided into blocks. Let's say it given a 64 MB. So this is the default if you get into a 25 MB data. So this is the default configuration inside Hadoop. It will convert into a different blocks, and each block is by default having 64 MB of data. So it is once you configure Hadoop, you can configure to it's not fixed but it's default, so you can change also, so it's configurable. So 64 MB in first block, 64 MB in second block, 64 MB in third block, then 33 remaining in fourth block. So this is how the HDFS get the whole file as a big chunk of data and divided into this different blocks and distribute it across different data nodes. So let's say if you got 503 MB of data, so by default it will divide into 128 MB, 128 MB, 128 MB, 128 MB, and 1 MB. This is how the whole HDFS divide the data. Excuse me. So here single block, how we are going to see, let's say we have 4 blocks of data, one block in data node 1, second block in data node 2, third block in data node 3, fourth block in data node 4, having different colors you can see. So different blocks. So datas are residing the blocks. Let's say NameNode given the task, each one is performing their task to analyze the words and how many number of political parties names is being used. So it's doing the computation in block 1, block 2, block 3, block 4. So what happened if this data node got failed? So these blocks get corrupted and is not reporting back to NameNode. So and other threes are performing their task fine. So to overcome this problem, what HDFS will do, it will create the replication of this data node in another data node. Means keep a backup copy of this data node into another data node. So if it fails, it automatically detects that okay, one data node got failed, then finally it will find okay, the backup of the data is where backup of the data is in which data node. So it will get back that all these information are reside in some metadata of this name node. So it will get back to the data node where the backups of that particular failure node, and again start the computation process. So this is how it's deal with the failure. So this is a two block replication, means it is keeping 2 copy of particular blocks. So let's say here you can see one in each data node we have 4 blocks, and we are keeping 2 copies of each blocks. So 1, 2, 4, 5, you can see 1 is here, 2 is in this data node, 5 in this data node, 4 is in this data node. So in case of let's say NameNode is performing some operation in between, it detect that this data node got failure. So immediately identify okay, where is this where is this block, 2 block is present here, it will come to here and it will assign the work to this block. So as a user you won't have any feelings that anything got failure. So this is how it very resilient. So what happens here, we are keeping two backup copy. Let's say this also got down, this also got down. So now both the data node got down. So again there is a concept called replication. So 3 block replication. So let's say we have a 5 blocks. So we want so it's a configurable how many number of copies you want to keep a backup. So let's say here we have 5 blocks, we want to keep 3 copies. So total 15 blocks will be needed. So each node we have 3 blocks, so 5 nodes is needed. So this is how we can configure the replication factor in HDFS. Once we'll doing installation and all, we'll see in this practical. So this is what I already discussed. This is just the written NameNode. What is it? It keeps a record how the files in HDFS are divided into blocks, in which nodes these blocks are stored, and by and large the NameNode manages cluster configuration. It maps a file name to a set of blocks. It's record each and every change. That's the master work. NameNode is also responsible to take care of the replication factor. That's what we just discussed, the copies and the backup of the blocks. In case of data net failure, the NameNode chooses new data nodes for new replicas, balances disk uses, and also manages the communication traffics to the data nodes. Then what is the work of data nodes? They are also responsible for creating blocks, deleting blocks, and replicating the same based on the decisions taken by the name nodes. The data node stores each block of HDFS data in separate files in its local system. When the data nodes gets started, they scan through its local file system, creates a list of HDFS data blocks that relate to each of these local files, and sends a block report to the name node. That is called heartbeat. So this is, you can see HDFS full picture. So this, we discussed name node, we discussed secondary name node, we discussed data node, we discussed heartbeats, we discussed replication. But what is balancing? Let's say you have created, you configured your Hadoop file system HDFS having a replication factor 3, means you're keeping a 3 backup copy. So let's say NameNode assign tasks to this data node, this data node, this data node, every node is performing. You can see the same color is representing the copies of the blocks in the different data nodes. So 3 copies. For this red one we have 3 copies. One copy here, second copy, third copy. Okay. So let's say in between this block got a failure. NameNode identify that. It will went back to another set of available backup. Again, let's say this also got down. Let's say this also, again it went to this block, this again went down. So we have created 3 copies and it went down. So how to overcome this problem? We cannot keep increasing the replication factor 3, 4, 5 because it's this NameNode task become very complex. This is a highly intelligent system. Think about a lot of programming is involved to do all these things in number of clusters. This you're seeing only the 5 computers. It can be deal with the thousands of computers, millions of computers in a cluster inside a data center. So think about that. It cannot create multiple copies. So what happened? The balancing concept came here. So to overcome this problem, what NameNode do? In case of failure of this particular block, and once it start going back to this node, this backup node, it will create a copy of this block to another data node. Let's say this data node. So we have another copy here. So let's say this got failed. When we move here, it can have before starting these blocks, before starting of this work of this block, NameNode creates a copy of these blocks again. So there will be always a one copy is always available. So that's how the balancing concept solves the purpose of if your replication factor reached, and how to overcome this problem in case of your backup copies got exhausted. So that's how with the HDFS full picture you are able to see. So that was that's all with this video. We have covered each and every detail of HDFS, how the internal of HDFS works. So thanks for watching. If you liked it, please like, share and subscribe my channel. Thank you very much. Have a good day.